For all these questions where they give us a quadratic function and they're asking about the minimum or maximum, they're really talking about the vertex, and which the real goal is to read the question and figure out if it's the x value you want or the y value you want. In this problem, we can see that they're making some x-ray machines, and there's a cost associated with making those machines, and x represents how many machines they're making, and then c, which is often also where the y would be, is the cost. And they're asking, what is the minimum cost? So to do this, since the cost is what's normally represented by the y, we basically just want to find the y value of the vertex. And we're going to use all those same skills we used to find the vertex of a parabola. It's just going to be in this context. So if I'm going to figure out that minimum cost, I want the y value of the vertex, but of course I first need the x value of the vertex. So I'm still going to start this off with the opposite of b over 2a, which in this case will be 240 as the opposite of b, divided by 2 times a. And when you do this calculation, you find out that this is equal to 200. In the context of the problem, since this is always the x value, this is telling us that if I make 200 machines, I'll minimize cost, because they told us x was the number of machines. But this problem didn't ask me how many machines I should make, it asked me what the actual cost was. So I'll take this 200, I'll plug it into this function, and whatever the answer is, that'll be the minimum cost. So I'm going to pause my video, but you'll just see the answer pop up any second. You can pause too and do it ahead of me if you like. Plugging that 200 into this function gives 0.6 times 200 squared minus 240 times 200 plus 35,581. Plopping all that in my calculator tells me the minimum cost will be $11,581. For the second problem, just set type. On this second problem, they're telling us about a ball that's being thrown in the air, and we can see that there's a specific function that defines its height. That function is given by the height h at any time t is 48t minus 16t squared. And the question in this case is, how long will it take for it to reach its maximum height? Now in this problem, you'll see that they have t in place of where x typically is, and again, h is taking the place of what y typically is. This wants to know how long it's going to take. So we're looking for a t value to find the maximum height. But because it's a maximum height, we're still talking about the vertex. It's just that I don't want the actual maximum height, so I don't want the h, I want to find the t. So I'm going to bust out that opposite of b over 2a formula yet again, and as soon as I figure that out, that'll tell me what the time is of the maximum height. This particular problem has the added twist of putting the a value second, because a is always what's in front of x squared, or in this case t squared. So the maximum height will occur at what's normally the x value of the vertex, which will be the opposite of b, so negative 48 over 2a, over 2 times negative 16. And if you put all this stuff in your calculator correctly, you should get an answer of 1.5. So the best answer here is, how long will it take to reach its maximum height? It'll take 1.5 seconds. If the question said instead, what's the maximum height, instead of when's it happen, I would take this 1.5, plug it into here, and that'd be the answer. But as it stands, this would be the final answer to this particular question. It'd be the x value of the vertex. Good luck.